Hello, you've just pressed play on an hour-and-a-half long video of me assembling this PiDP-8 kit. So that makes you my internet friend. And as my internet friend, I think I owe it to you to give a little introduction and explanation of the video you're about to watch, or at least skip through. I received this kit quite a while ago, and I recorded the process of assembling this. I decided that I would try to capture it. I had 3 cameras set up, multiple angles, 3 days of assembly, tons and tons of raw footage, during the process of which a lot of times I would lean over and get my head into the shot, or the battery would run out on a camera, or the memory card would fill up, or I would just be in the middle of something and not realize that I was not making a good recording because I was in the process of trying to put this thing together. So that footage sat around for a long time. I've assembled it into an hour-and-a-half. Maybe you're putting your own together and you want to see how I dealt with one of the issues, or you just want to put this on the background or whatever, that's fine. But I do want to say that this is an awesome kit. I really, really like it. I complain throughout the whole process because that's what I do. And I think there are some gaps in the documentation. There are some gaps in the process that make it a little bit more difficult than it needs to be, but this is kind of somebody's labor of love, so I don't mean to be insulting or offensive in that way. And as you can see, in the end, it does go together. It works great. If you're not going to watch the whole video, if you're interested in the PiDP-8 replica itself, just skip to the end of this, because I have the whole assembly here. And I do all of the electronics and soldering and things and put that all together. And then there's a point where at the end it ends rather abruptly, because I say, well, now I have to do some work on the box that it goes in. And unfortunately, I took it out to the garage to do some woodworking things, and I didn't record any of that. So the whole thing just sort of just peters out without a conclusion. So I'm going to, at the end of this video, I am going to add in kind of a review and summary of how this thing went and what I think of it, and and other stuff like that. So this is the intro, me telling you about what's about to happen, and then there will be a bunch of stuff, and then at the end of the video I'll be back to actually talk about the PiDP-8 replica and hopefully sum it up. Enjoy.
Hello internet buddies. Today I'm going to be assembling this PiDP-8 replica front panel kit. It has a circuit board here that I need to put a lot of lights and switches on, and when I get that all together, I'll be attaching a Raspberry Pi to the back of the board, which will run an emulator, and it'll give me all the blinking lights and a simulation of an actual PiDP-8. So this ought to be fun. It's going to involve a ton of soldering, so I will be recording this, and we'll see if it is if there's even a video worth assembling out of the end result. But certainly when I get the thing done, I'll make something so we can see how it works. And I'm gonna get going now, because I suspect this will take quite a while. Alright, so before we even start to put the PiDP-8 together, they recommend that you get the emulator going, the PiDP. There is an image on the website of the guy who makes this thing, and he suggests you use his. It's not, strangely enough, it's not compatible with the Pi 3. So I have a couple of Raspberry Pi 3s lying around, and I can't use them for this, at least not trivially. So I'm going to use this Pi 0W here because it has the built-in wireless. I also have I think I have a B+, which is compatible with this thing, but then I have to add a Wi-Fi dongle, which is annoying. So I'm not going to do that. What I am going to do first is to actually, interestingly enough, it says B+ GPI. Well, not going to worry about that. Okay, so I think the way, I just want to see how this is going to go together. One of the problems with these is you could put the connector on the wrong side. It's kind of obvious, but not always obvious to everyone. So this is starting to get on my nerves. Okay, here we go. I found the connector. So this is going to go, I think this is, yeah, that would make sense, because if this is the front and this has got all the LEDs and things on it, then this will sit on the back here. Ha. And then this will plug in to there. Not too bad, all will be well. So, let's set that back aside. And there are two things to do. First of all, I'm going to have to download the software. And imagine going back in time and telling the people who made the original PiDP-8, even that this is a small one. This is a 16 gig micro SD card. I usually try to have a few of these lying around just for Raspberry Pi images, since it feels wasteful to use larger ones. I'm having a lot of trouble opening the packaging. Okay. Now I have to do two things. I have to download the image for this, and then I have to put it on this card, and also I have to put a header onto the Pi. So I better go get that. So here we are about 45 minutes later. I have struggled with the most basic things. I haven't even gotten to the soldering yet. It's always software. So the Raspberry Pi, which is known to suck, sucks. And to find a working, I'm not even going to get into it. Just suffice it to say, I've spent 45 minutes. It's now 11 o'clock at night, and I haven't even gotten started on this project. So let's see what we will see here. The number one reason people struggle with kits is bad solder. Okay, that's fine, whatever. I need your advice like I need a hole in the head. For all components, pause to think on which side of the PCB they should go. How about this? How about for all components, you tell me which side of the PCB they should go on, considering it's your damn kit. Now, I need some kind of tray. Yeah, before I start here, I'm going to sort out all of these parts, since it is rather messy assemblage. Start with fitting the 26 diodes above the switches on the front side of the PCB. I'm going to set aside the LEDs, the resistors, the ICs, the screws. There are diodes, 26 diodes out of 27. Comes with 27. Supposed to attach 26. Here's the board. Start with fitting the 26 diodes above the switches on the front side of the PCB. Proceed with the 3 resistors close to the row of diodes also on the front panel, and the block of 12 resistors in the back of the panel. For diodes, polarity matters. Check that the black stripe on the diode matches the stripe on its PCB footprint. new since June 2016, solder 27th diode in the back at the back of the PCB, the white line underneath the IC. Okay, that apparently is that. These would appear to be the diodes. 1, 2, 3, 26. Just a sanity check there, which is sometimes important. Spacing. I'm just going to do one because at this point I need some kind of validation. Life is on the right track. Here's what I'm going to be doing for a while. Take the gloves off. Taking the gloves off, man. Okay, here's the plan. I'm going to do these, let's say 5 at a time. Let's just say that, 5 at a time. See this because it doesn't matter. It's a pain in the ass is what it is. Just have to deal with it. This is a very tight footprint for an axial through-hole component like this. So the I have a little lead bending jig, but it's just the tiniest bit too big, which I guess I could make another one smaller, but you know, the fact that it's slightly too big might help here in a way because these are tighter, I guess. I don't know. Anyway. I am going to attempt to solder this batch and then move on and just keep doing them in batches of 5 or thereabouts. Not too thrilled with. I was hoping that I'd be able to sort of push that down and everything would stay, but it doesn't seem like it's working. I'll do what I can. Alright. Looks like 5 at a time is the plan. Okay. I put all of the diodes on. That was tonight's project. It was a big pain, but all of these 26 diodes and the 27th one on the back have been fitted, soldered, trimmed, etc., etc. And it's almost midnight now, so I'm going to, I guess that soldering took about 45 minutes, and yeah, I'm gonna let this go now. We'll finish this tomorrow by putting the rest of the LEDs on, the IC, and the connector for the Raspberry Pi, some resistors, and then it should be, oh, and the switches, a lot of work. Should then be able to fire it up and check it out. Till then, bye. So last night all I managed to do was get all of these diodes installed, and I was going to try to get quickly, I have a lot of things going on today, so during a brief break in the action, I thought I would try to get as many LEDs soldered as possible. So first I wanted to refer to the website, which has the reference on which way the LEDs go, because they're not marked on the board, unfortunately, for polarity. So I, of course, logged into my Windows PC here, which is not my operating system of preference, but it just happens to be nearby. And of course it was busy doing a Windows 10 Creators update. So I thought I'd complain about that for a little while, but it seems like the update actually finished while I was complaining. Excuse me. Pardon me. So this is not going to be about that. Instead, I will go and refer to what I wanted to refer to here, soldering. So we did the diodes, and now we install 89 LEDs. There's a bowl full of LEDs. Now, if I somehow get this wrong, I want to be able to say that I was careful here. And I'm going to read this verbatim. Now come the 89 LEDs. On front side and polarity matters. The long legs must be facing the left, closest to the Raspberry Pi. Just to leave no doubt, the short legs should be facing the end of the PCB, which has the PiDP logo on it. Okay. on the front side, this would be the front side, the long legs must be on the left. The long leg is on the left, closest to the Raspberry Pi. Now the Raspberry Pi is on the back, so I suppose, you know, if you're sticking this through these holes, then that makes some sense. So on the back, this is the Raspberry Pi, and the long leg is on the left, closest to the Raspberry Pi. Just to leave no doubt, the short leg should be facing the end of the PCB, which has the PiDP logo on it. Well, I suppose that's the PiDP logo. It's really just text, but we'll take that. Okay, so this is definitely the right way with the long leg on the left. Long leg on the left. And so now I have to solder an LED to every single one of these footprints here. Now, I suppose I could try kind of the way I did before, doing them in a little bit of a batch, but not all at once. He's got a video of, you know, a quote efficient way to solder them, which is not my preference because it involves sticking solder onto the soldering iron tip and then using that. I don't, I mean, I'll do that in a pinch, but it's not usually my preference. I think what I'm going to do here is, first of all, let's get everything set up for fume extraction, etc. I think I'll solder one leg and then, yeah, I'll go down and I'll solder one leg of each one, and then I'll straighten them up and then come back and solder the other ones. In fact, I think just to give this some kind of stability here, I think I'm going to do a strategic / tactical combination of LEDs here. Okay, so this should get me, hopefully if I turn this over quickly enough they won't fall out. There we go. My hope was that if I did this correctly, the board would sort of sit flat on the table. All right. Here's the plan then. If I stick this on there, nah, that might be a bad idea. That could end up with you know what, you only live once. Okay, we're gonna do this. We're going to do this. Ready, kids? See, actually these are all kind of flush on the board. Not much needs to be done there. Just gonna do this once to see if it makes any difference at all. You can kind of tell when they move, but I really don't think that was a big deal. So let's get going here. Finish this. All right. This is good. going to go relatively easily, I think. I think I'll trim these leads so that I know which ones I've done and which ones I haven't. And then I'll come back and put some more in. And it should go pretty smoothly. That's a good start in the LEDs. I am out of time. I have to go do something else for a while, so I'm going to come back to this later. And we're back. I've gone off to do some other things for a while. I've got half an hour before my next trick. So I'm going to try to put another row of LEDs in here. Let's see if I remember the rule. The long leg goes toward the Raspberry Pi, the short one toward the logo. This is so exciting, isn't it? Loading these LEDs into the board. I think I could do the whole row at once this time. Come back, press really hard on that so that it goes flat as I melt that connection. One of the tricks I found is to keep holding it until it cools. Previously I was in a hurry and I would let go and the solder would still be melted a little bit, and then it would move after I took my finger off. So this time, keep up the pressure until it's definitely not going anywhere. A little visual inspection before I tack the other side down. They all look straight, they all look flat on the board. Well, there we go. Came down here at 2:30, it's 2:56, and I seem to have finished all of the LEDs. So let's turn off the noisemakers. And what I'd like to do is test them all. Just going through here and verifying that these dimly light Okay, well that one's questionable. I may have a diode here that is blowing. thing this way. Okay, I'm going to take that one out because it seems to be bad. Good thing I tested. Yeah. This one's faulty. Tested everything, even fixed the thing that was broken. And I can go deal with my other project. I'll come back to this afterward. Put the resistors on, put the switches on. Put the IC on. We'll be ready to go. And we're back again. Time to put the next set of components on this board. Let's see, we did the 89 LEDs. Now it says to solder the IC socket. That would be this socket here on the back side of the board. Make sure it sits with pin 1 facing down to the switches on the opposite side of the board. So that would appear to be the IC socket. Pin 1's the little notch. So line the notch up with the bottom like so. And that ought to do it. Wait, what about the resistors? I missed the resistors here. Ah! Start with fitting the 26 diodes. Proceed with the 3 resistors. Ha 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 ha. I'm not going to put that on right now. I mean, it doesn't... It's not like the order here is super critical, but I was trying to follow the order, and somewhere along the way this is written, it's divided, this web page is divided into paragraphs in a very strange way, but whatever, I can complain about these things. Okay, proceed with the 3 resistors, 1K close to the row of diodes also on the front of panel, then the block of 12 resistors on back of panel. This is what I was looking for. So they've given me 4 resistors. I'll just assume that those are spares, or just it's hard to count. Okay. Looks like the hole spacing for the resistor is the same as for the diodes, so I'm going to bend them the same way. Let's give me 3 resistors, brown, black, red. That's 1K. Did I say 10K? 1K. 1K resistors. 1K resistor. 1K resistor. 1K resistor. 1K resistor. Okay. Not okay, 1K. There should be a third one somewhere. There we are. 1K x 2x. This is the x and x times 2 ohm resistors must be left out. They're not included in the kit anyway. Okay. But I suppose I put the 1K in that's next to the 2 that I don't put in, just to be extra confusing. Okay, so there are 3 resistors. Turn on the noisy extraction fan again, and as I do, get my face right in there to solder these. This black solder mask makes it very hard to see. That was easy enough. So now, trim the leads from the resistors. If only they could all be this easy. Now it says that I'm supposed to put a block of 12 resistors, 390 ohm, on back of panel. Aha! So there's a whole block there that goes under the Raspberry Pi. They appear to have the same spacing as well. And that would be these. Slightly more precise. This is slightly more annoying than putting those LEDs in. I didn't think it would be. I'm basically only reading the bare minimum that I need to follow the instructions here. So there's it keeps making reference to serial port. I don't know anything about this emulator. I don't know what these options are. I guess the serial port would be like, so you could run this standalone and hook up a VT100 or something. That would be kind of cool. I don't know why you need to get this board involved in a serial port though. So I'll have to read up on that. Okay. This should be relatively straightforward. Let's see how we do here. Okay, that's the resistors. I have to go do other things now. Back to the so-called real world. Next batch of soldering, though, should be the end. I feel that I'm somewhat into the home stretch here. We've got the diodes, the resistors, and the LEDs on the board. The resistors on the back. So now we're back to where I was just a little while ago, or in real time several hours ago. I was about to put this IC socket on here when I realized I hadn't put the resistors on yet. So, resistance being useless. Alright. Get this going. As usual, I like to tack one corner down to start. And then make sure that it's pressed in there solid. And then I'll tack the opposite corner down. There are two things about this. One is you don't want to use too much solder for a socket like this, or it can actually go into the socket. And number two is it's very easy to burn yourself doing that because the heat is transferred through to the other side. And so when you've got your finger on there pressing down, not unusual to suddenly realize that you have a 650-degree soldering iron. Yeah. That is the IC socket. And now the Raspberry Pi header, which they remind you several times to not solder to the expansion connector. There's an expansion port over there. Do not solder Pi connector here. So this is not keyed or labeled. So we will just make a go of it. That's the pi header. Now what? Mounting switches. I'm going to read this carefully. There are brown switches and there are white switches. There are momentary switches and there are toggle switches. So what I'm going to do is sort out the toggle switches from the momentary switches, because the colors don't necessarily indicate which are which. You see. Alright, so you've got 5 momentary white switches and 1 momentary brown switch. And this claims to be the most important part of the instructions, is to put the switches in the right place, and that they have to be in a straight line the first time. And there's a fail-safe procedure. So, take 2 brown toggle switches and solder their... Take 2 brown toggle switches and solder their mount or tab, i.e. the metal lip, into the left and rightmost slots of the provided switch bracket. Make sure the switches sit straight, snug against the top right of their slots. Press your soldering iron into the corner made by the center top solder pad on the bracket above the switch tab and the top of the switch tab, then let an ample amount of solder flow. No need for cosmetically precise soldering. This will be invisible later on. Okay, so let's try to understand what they're saying here. Take 2 brown toggle switches. These are 2 brown toggle switches. And solder their mount or tab, i.e. the metal lip, into the left and rightmost slots of the provided switch bracket. So this is the switch bracket. Now, that might be the leftmost slot. It says tog brown on there. And then the rightmost would be over there, obviously. So these, I suppose, will eventually go into these holes. Some of them will. Maybe someday. So it looks to me, okay, I get the idea. So these are going to go in there. And then eventually this bracket will go on there in some way. Yes. So for some weird reason, he's designed this so that the leftmost one, I'm just going to shove one into this hole just so I can see what... this is very difficult. These don't go in the hole. So if that goes like that, there's the bracket. And that's going to go in there. Right? Okay. And then I'm going to have to put the next ones in. I don't know, man. I'm concerned. But anyway, what they appear to be saying to do here is to snug against the top right of their slots. Well, their slots are very small, and there's not a lot of room to wiggle, but whatever. So I'm supposed to push that up against the top right and then solder the tab, this tab onto there. And then the next one will go into this hole, but geez Louise, how can you possibly get that into that hole? It doesn't fit. They all like that? Yeah. I mean, there's a suggestion that this would go into this bracket, but damn, it's not going to happen. I'm going to be struggling with this bracket. So these pictures are very small, which doesn't help. Small and misleading. Would it have killed him to take a clearer picture? White, brown, brown, and then the end. But then the one he's got over here is brown, white, 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 momentary brown, white, 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 and then he's got it in there rather than on the very end. Why? Like, are you trying to make me crazy? You are trying to make me crazy. Okay, that one fit in there. Yeah, I think there's a problem with the way these holes are routed. They get smaller and smaller as it goes to the left. Yeah. Till eventually they don't work anymore. That's super annoying. See what they did? See what they did? Over on this end, switches fit in here with plenty of room to spare. And then as you go further along, they start getting tighter and tighter and tighter and tighter, and eventually you can't get that in there anymore. Yeah. Damn it. Something wrong with the CNC. That's really annoying. So this looks to be 10, 11, 12, 13, just over 13 millimeters high. And 10, 11, 12, just under 13 over there. So some piece of machinery has malfunctioned. I'm going to have to fix it. But how am I going to fix it? Well, this will be ugly and unpleasant. Don't breathe this. If I can get this to go in, then I'm not going to file it. Well, that's a bit unpleasant. Now that I've got, try to clean this up a little bit. Fiber press dust all over the place. Let's see if I can do this now. These are all toggles, right? Okay. I still don't understand. That definitely has to go on there, right? Because that's DF1. This weird, like, half cut off bracket is not helping anything. I am going to put this in the hole because otherwise it's just too hard to solder. How am I going to solder that in when it's, you know, it's hanging off the side? Doesn't make any sense. I'm going to do the best I can, that's all. Just the best I can. Okay. I have to go over this again. Take the two brown toggle switches and solder their mount into the left and rightmost slots of the provided switch bracket. Make sure the switches sit snug against the top of the blah 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 blah, solder all this. Then the next bullet point says mount the bracket with its two switches onto the PCB. Note, please read, often ignored, the two outermost switches on the PCB will fit in the side cutouts of the bracket, and these two outermost switches will only come later, last. You are now mounting the second switch from the right and left. Well, that's obnoxious because you should tell people that rather than to put it on the outermost one. Whatever. I don't care. Okay. I'm gonna do this. We're gonna make this go. We're going to make it go. Center top solder pad snugly against the top right. See how easy this is? Trivial, really. Hands. I'm going to do this. Let's get this off the tape. Okay. That's one hand taken care of. I've done that adequately. Now, in theory, mount the bracket with its two switches onto the PCB. So I'm supposed to be able to fit these switches into here. Quite warm. And then do what? So only one pin, ensuring they are pushed in full and straight. It's in, let's solder it. before things get out of control any more than they already have. Check that. Momentary switches are all operated by temporarily depressing the lower part of the switch, so mount them such that you momentarily press on the bottom half of the switch. You do this wrong regularly. The lower half sticking out in the front. Okay. I get it. I get it, man. Relax, alright? Okay. Is that it? All the switching? I mean, all the soldering? That's it though. I think I'm done with all the soldering. Okay. There's some hardware on one of these. There it is. So here's my Pi. I'm supposed to mount that how? Use the 3 nut spacer screw sets. You need to snip off about 1.5 millimeters from the top of the nylon spacers because they're a bit taller than they should be. Oh, Lordy. So apparently we mount the Raspberry Pi in there, like that. Okay. Also, you may notice the Pi connector is about 0.5 millimeters too short to let the Pi be pressed in fully. Do not worry, it is not a problem. Okay. Also, there are 3 of these, which seems a bit daft, considering there are 4 mounting holes. You know, which 3 should I use of the 4? I'm going to go with the 2 furthest away, plus, I don't know, 1 at random here. Now he says the spacers are too long, but he also says the socket is too short. So, you know, which is it? Gotta trim this down, but if I trim it too much, then he's like putting it on me to trim 1.5 millimeters off of this spacer. Like, thanks, dude. I'm just going to move on with this. I'm going to take these. After all that other stuff that required such careful alignment, double, quadruple checking. this one part. It's like just cut off bits of that. Just cross your fingers. Red light's flashing on the Sony. I think that's running out of space on the card. The Raspberry Pi is mounted. Power this up. There are a bunch of lights flickering. I have no idea if that's supposed to happen. I guess it is supposed to happen, because it does happen. It seems to be running. So let's see what this, if this guy says, well, let me see. Now I'm going to press stop. See if it prints anything on the screen. Nope. If the front panel lights up, use the stop switch. The blinking should stop. Stop. Press the leftmost 18 switches to their down position, which is binary 1 or on. Hit the load add switch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then you press the load add. One of them did not light up. Interesting. On the top line, all 18 LEDs should light up. 17th one did not work. SR11 or that LED. One of these things is not working. LED is red, so let's see if continuity test. First I'm going to switch 10. So here we are on day 3 of the PiDP-8 replica front panel build. The whole thing is assembled, tested, everything's working. The remaining chore is to install this in the box and then put the front on it. Now this is a couple of interesting things have cropped up here. Just want to talk briefly about this design itself. Most of this is pretty clever. I mean, I like the general approach. The switches are fun. The LEDs actually look really nice. The idea that the Raspberry Pi just plugs into a socket on the back is pretty good. I did have one broken part. So there were spare LEDs, there was I think a couple spare diodes, one spare 1K resistor. None of the spares for the other ones on the back, and no spare switches. So I don't think that there was intentionally extra parts here. I think it probably is just that it's not worth the guy's time to count them carefully. And as long as you get the minimum you need, then that's fine. And if there are a couple extras in there, so what? But the switches are probably counted pretty carefully because they're expensive, and also they need to be particular ones, right? You need to have the right number of white toggle switches, brown toggle switches, and brown and white momentary switches. So anyway, to get to the point here, one of these switches, the one that I installed as SR11, after putting the whole thing together, remember I tested all the LEDs, I made sure they were good. Actually, one of the LEDs was bad, so I did have to use the spare. And then it turned out one of the switches was bad. So the only actual like test besides booting it up and seeing if things blink that is mentioned in there is to turn on all 12 of these switches, and then when you press load address, that will load it into the address bits at the top here. So these should all light up. Now the second to last one wasn't lighting up. That corresponds to switch SR11 here. So either the LED was bad, or the switch is bad, or the connection between the switch and the Raspberry Pi is bad, or I suppose the connection between the Raspberry Pi and the LED is bad. But anyway, you could see the LED flashing at other times when the code's running, so that ruled out the LED being bad. I did test it just to be sure, and then so then I tested the switch, and that, that's easy enough. Just put a meter on there, check the continuity. Turned out the switch was bad, so this switch was not working in the on position. But these are dual throw or dual pole. Anyway, I always get that mixed up. But they have a contact for off and they have a contact for on. So the contact for off was actually working when it was in one position, and the contact for on was not working in the other position. Or it's arbitrary though, right? That's the point, is it's arbitrary. So once I realized that that was the case, then I desoldered the switch and flipped it over and installed it the other way around, and so that got it working. Fortunately, the off position, there must be a pull up or pull down or something so that it doesn't matter that it's not connected, it's just floating when it's in the other position. I still, maybe I can get a replacement switch just to have everything 100%, but that's the only problem I had electrically: a bad LED, a bad switch. Everything else seems to be fine. So let's talk a little bit about the physical assembly. This is, I think, the place where this really falls down. Apparently this kit has a couple of different revisions, so there are some differences depending on which which one you've got. But the problem I've run into is with these wooden blocks. So the instructions say that you're meant to install this long block here so that it's hanging off the end of the board by 2 millimeters, or depending on which part of the instructions you read, either 2 millimeters or 1 millimeter. Now there is a connection here for a serial port, which obviously you don't want to block that with the block, right? So it is important that it be shifted over that way. And apparently it's supposed to hang off either 1 or 2 millimeters on this end of the board. And then it's not entirely clear why, but it says that that's necessary for the front panel to be able to attach the front panel correctly. And then, so you put the long one on, and then you put this shorter one on next to this IC here. Now, as with several places in the instructions, it tells you one thing, and then you get a little bit further, a paragraph or two later, it says, oh, by the way, this is very important, and then tells you something that it didn't tell you the previous time. For example, it says in step 6, there's 3 blocks of wood in the kit to mount the PCB in the case. Now there are not actually 3 blocks of wood, there are 2 blocks of wood. So that can be a little bit confusing, that must have changed. Then the instructions tell you to put the long block, slide the long block under the PCB. There's a bullet point that says align the end of the block to the right side of the PCB, then let the block stick out 2 millimeters from the PCB edge. See photo 1. When you see photo 1, photo 1's caption says fit first mounting block so it sticks out 1 millimeter on this side. So it says 2 millimeters and then 1 millimeter. And then in the next bullet it says on the other side you should have 2 millimeters room for the serial port connector. See photo 2. Photo 2 says leave just enough room for the serial port header. And then the caption above the photo says, in summary, the mount block lies just above the switch solder lugs and should be shifted 1 millimeter vis-a-vis the PCB. Then later on, it says on the other side you should have 2 millimeters room for the serial port. So it's either 2 or 1, and it keeps flipping back and forth between. But it's a little bit annoying anyway, right? Like I should have to measure 2 millimeters. There's no like marking of where it goes. You just sort of have to either eyeball it or measure it. So I measured it very carefully. I left 2 millimeters sticking out on the edge. Now, then, well, let me just, then I'll talk about that, right? So here's what happens when you do that, okay? Then this goes in here and it gets pressed against the bottom right, okay? So when you press that against the bottom right, now that block, this has got some room to shift a little bit, right? So when you press it against the bottom right, that block is essentially pushing this so that it's not all the way against the right. It's pushed back 2 millimeters, okay? Then when you put the front panel on here, the acrylic piece, which is quite tight, this box, what I found was that the LEDs and switches were all shifted to the left with respect to the panel. So it's visibly off center with that 2 millimeter block. So I took this all back out of here, unscrewed it, and it's a pain in the butt to screw in too, because you have to reach through the holes in this mounting thing in order to get to that screw, and any normal size screwdriver doesn't fit there, so you have to use a tiny little screwdriver to turn a screw into a piece of wood. So I took that out, I flipped the block over, I'm like, okay, I've already got holes in there, but I'll do the other side. I'll just do 1 millimeter. So I inched it back just 1 millimeter, and I found putting that in there, 1 millimeter was still too much. So at that point, I'm kind of stuck. I tried to then redo it and make it completely flush, because I don't really understand the whole point of why that's supposed to be there in the first place. But even when I put that back in, unfortunately, it shifted as I was putting the screw in, I guess, or maybe it went into the existing hole. I thought I found a way to do that, but I might have to just cut another block of wood myself. Or maybe I could take this off and just sand that down or something. But anyway, that's annoying because, yeah, I want the lights and switches to be lined up correctly after all of that work, and not have this shifted. So I really don't get that step. Step is a bit irritating. Then you put this small block on, and it says in the instructions here, keep 1 millimeter distance between IC and wooden block important. And then in the caption here, it says second mount block, keep it 1 millimeter away from the 2981 IC. It matters. Why does it matter? Maybe you could tell me why it matters. It's also a bit frustrating because because there's no space to put this block here between the where the component leads are not, it doesn't sit flat against the board because there are all these little bits of metal sticking up from where the LEDs were soldered on. So I I completely missed the leave 1 millimeter part, and I don't know why that's important, and I didn't do it. And so, I don't know, perhaps the world will end. It's not clear. Anyway, after you've done all of that, then you put the PCB with mounting blocks into the case. The metal bits of the switches covered up with black tape should rest into the lip of the case bottom on the inner edge and against the outer edge. So that's how that's meant to go. Now, you might be able to see here, if I push that up, that there is a considerable distance that in order for these tabs to rest on that lip, this board has to be actually, these blocks are not touching the back properly, so that the board ends up at an angle. Obviously not that dramatic. And it does say that in here. There's variation in the depth of the bamboo cases. Check if the PCB is sitting flat in the case. If it leans back a bit, tape a 1 to 2 millimeter bit of cardboard to the back of the short wooden block so the PCB sits level in its case. I mean, all of this effort to put this thing together, and like you're eyeballing stuff with wooden blocks and cardboard and tape. And so then keep the PCB in this location and note the position of both mount blocks in the case, and then now you put screws in from the back. You can't really see where so I guess I'm gonna have to do that cardboard trick. The other thing that's a little bit frustrating is, let's just pretend that that's installed. Okay, so this is kind of tight, fine. There are two things that are very, very strange here. Okay, so now if we put the acrylic front panel in, it's very obvious in real life. The camera might not pick it up, but the acrylic will not go down on the bottom. On the top, it fits inside of the lip in here very nicely. On the bottom, it doesn't. It's sticking out, and it's not going to go in there. And the reason it's not going to go in there is because those switch tabs are in the way. It's not even debatable, right? There is something. These metal tabs are sitting on that lip, and so of course you're not going to be able to. This would have to be deeper in order for that acrylic to fit on there properly. In fact, maybe the thing to do is for me to just sort of route that out in some way so that it goes further down. It's not clear whether that would be a good thing or a bad thing. I think I might actually do that, so I have to make a bunch of modifications here. Yeah. And then those will fit in there, and then I'll be able to put the acrylic on and it'll actually go all the way in. See, if those switches weren't in the way, just take this board back out. This fits in there just fine. But yeah. Okay, so that's that problem. So now at this point this is where it gets a little bit frustrating. There's a Raspberry Pi mounted onto the back of this board, right? So and here are the USB ports and Ethernet port. Power's on the top, HDMI is on the top. So this is going to sit in there like this. Now, in order to get access to those ports, you have to cut a hole in the side. It doesn't come with the hole pre-cut. I suppose that could be slightly convenient since you don't know, maybe you're going to use a Pi Zero or something, I don't know. But regardless, that there are some measurements on the site that tell you, to measure from the bottom corner and cut a hole in this area. I guess, given that everything has been off slightly so far, I'm a little bit concerned about following those instructions. I'm going to try and make my own measurements. That's not the biggest problem. I think the biggest problem is, well, the holes in the side. So this is gonna, it would be nice if all the connections were in the back, right? So if you have this sitting on a shelf or something and it looks nice, instead it's going to have like USB stuff sticking out the side. Okay, and you say, okay, fine. Well, the power, you don't have to do that, right? You don't have to plug anything into the side. Well, you kind of do, because it doesn't work with the Pi 3, which has built-in Wi-Fi. I'll have to see, maybe that's just the software and I can recompile it and make it work. But so I've got a Pi B Plus in here. It doesn't have built-in Wi-Fi, so the only way to get network on here is going to be to plug a Wi-Fi dongle into the Pi, and that is going to stick out. There's not enough, there's no clearance in here at all to be able to just stick a dongle in there and not have it sticking out the side. So that's a little frustrating. Also, the serial port would be the same sort of deal. Well, I guess not. I guess you can put that wherever you want. You could route that. So, and then you've got the issue. Then they said to cut a hole in the top. This is really great too. There are measurements here somewhere for putting the hole in the top. Yeah, there's a picture and it's got the dimensions and it tells you how far to cut out a rectangle there so that you can access these ports. Which, by the way, note that those ports will be, there's all this gap here, right? So those ports will end up being, you'll have to reach in. They're not going to be flush against the side. But the best part is there's a whole picture with the diagram, and then on the very underneath, so you can't really see this on the camera, but there's a picture with a diagram. It shows you where to cut everything and so on and so forth. And then underneath the image, there's some text that says, warning, the measurements for the HDMI slot in the picture above are not correct. So if you actually followed those instructions, you would have put the hole in the wrong place. A little bit annoying. And then now you've got a hole in the top and a hole in the side, which doesn't make a lot of sense. So anyway, here's what I'm going to do. I would like to not have wires sticking out of the top in particular. So I have this panel mount micro USB cable. So there's just enough, I tested this, there's just enough room to be able to stick that in there. And when this board is shoved in, if I'm really careful and I bend it carefully, there's enough room there to get that. It may be nice if this were a right angle, but it's not. And so then what I would like to do is, if you imagine this board here and a nice socket in the back, right? So that'll be panel mount in the back, bottom corner where it belongs. However, take a look at this. Again, there are these wooden blocks here. Right? So in order to get the HDMI, sorry, the USB power from there to the bottom, the blocks are in the way. So I can either have the power connector in an annoying place, like the middle of the back top, or I'm going to have to notch out one of these blocks, and then I can route it around to the back. So that's what I'm going to do. So I've got to make quite a few modifications here. I think I will. All right, I will notch this down so that I can set this in here flush against the back. Hopefully that'll be okay. I mean, if it's not, that's fine. I can raise it up. The only reason I might not want to do that would just be in case the LEDs are too far back and they look weird. But I think that'll be fine. Because I think what you're meant to do somehow, I don't know if that's in the instructions and I missed it, but there's a section, you know, when you put all these switches in, it's really like keeps telling you about how important it is to have them aligned perfectly and make sure they're all at the same level and everything. So I pushed them in. I pushed them in as far as they would go, and then I soldered them at that level. But I think there's actually some intention that you're somehow meant to not push them in all the way, and so that there would be maybe a millimeter or so of extra distance between the board and this tab. But where does that come from? And that's It's crazy. So anyway, this is a really cool project, but now I have to go do some woodworking. So we'll see if I can get that straightened out.
So as promised, I am going to summarize now what happened after I said I have to do some woodworking. But first I'd like to just briefly comment on this product here. This is an awesome thing. The kit is amazing. The final result, I love it. It's one of my favorite things. It's well worth the quite modest investment to get this together. And the switches are fun to switch. The thing works great. It looks great. So despite, you know, various whining that's gone on in the video, the reality is that this is fantastic, and it just takes a little bit of work to put it together. No big deal. That's the nature of things. So here's in the end what we ended up with here. I put the power connector on the back. I think I mentioned in the video that I had a panel mount micro USB connector. So I put that on the back here. Now it is mounted in a bit of a strange way. I put the majority of the connector on the outside of the box because it is quite tight inside here. You can see there are these 3 screws which get screwed through into those 3 wooden blocks that are inside that are on the back of the board. So that whole thing, kind of worked. I found it was a little bit iffy. You sort of have to just guess where to shoot these screws in, but in the end it was fine. I ended up taking this thing apart and putting it back together many times. I think some of these screw holes got a little stripped, which is unfortunate. But I guess what I want to say about the power connector in the back, I shouldn't have put this here. So when this is plugged in, my thought was, this will sit on a shelf most of the time. I don't want to see wires sticking out the top and sides and things like that. So there's a bunch of effort and extension things and right angle adapters and stuff inside of here to try to make this a reality. But when you plug in a USB cable into there in order to power the thing, this causes a bit of a problem, because a lot of times, if you're showing this to people or you want to work on it or something, having it like 90 degrees vertical is not ideal, right? So you want to sort of pick it up and lean it back, kind of like this. Well, that's in the way, right? It's not, you can't lean this back now because that wire is in the way. So I should have put that higher, probably, so maybe up there or something, or I don't know exactly where. But I felt like electronic products, they tend to have their power cord in the bottom corner somewhere, so I put mine in the bottom corner. If I do it again, well, we'll talk about that in a minute, I wouldn't do that in particular. So what else? Now we've got the side. Let us address the side. So this is what I ended up with in order to be able to stick a USB cable into the side. Sorry about the focus on the camera. So there's something a little bit complicated about this. Originally, when I put this together, I thought that the instructions suggested that it was not compatible with the Raspberry Pi 3. So I used the Raspberry Pi 2, and the Raspberry Pi 2 doesn't have built-in Wi-Fi, so I had to install a Wi-Fi dongle. Now, even those little tiny mini ones that are only they stick, just stick right out of the USB jack, a tiny amount, are not going to work in here because this is basically flush up against the side of the box. So I had to make the hole for no other reason. I mean, I really had no intention of plugging anything in through the side, but I had to make this hole here in order to have a place to stick that Wi-Fi adapter. So that was okay. I mean, when it's on the shelf, I leave this on a shelf most of the time, and you don't really see that hole in the side when you're looking at it straight on. And the Wi-Fi adapter doesn't stick out past the side. But then after a bunch of things, I discovered that in fact there is a newer distribution of the software that's compatible with the Pi 3. And so all of that was kind of a waste of time, and I went and reinstalled it, got the new version, replaced the Pi 2 with the Pi 3. As you can see, there's nothing plugged into any of these because the Pi 3 has built-in Wi-Fi. So there's that. Now, what else? The other problem I alluded to in the video is that Here, let me pop the front of this off. The instructions basically say to screw this acrylic front on by drilling holes through here, through the plastic, and into the board somewhere, and I think right through the board. I don't remember, it's been a while, but I'm not putting screws through this acrylic, sorry, but no. Even if I do it carefully and don't crack it, I mean, I only have one chance to get that right, but that would look kind of ugly. Fortunately, the friction fit here with this box is quite tight, so I can easily get away with just sticking that in there. And if it weren't, good enough, I'd find a way to mount it without putting screws through. Okay, so where are we here? Yeah, so the Pi has, and here you can see a little bit, maybe you can see a little bit, I don't know, I should probably shine some additional light on that. The black on black board wasn't really helping, so you can see here I have a right angle micro USB adapter so that I can get into that power connection on top of the board. Now the other things on there include the HDMI port, and it is useful to have access to that if you're, have a problem with the operating system or something on the Pi. You really need access to the console in order to troubleshoot it. Otherwise, I don't really care about the HDMI port. I'm accessing this over, basically over a simulated serial console. But anyway, I did not want to put a hole in the top of the box, and I did not want to have to fish it through. So because of all those things, I decided, well, I've already got holes on the side and the back. Maybe I can put the HDMI connection on the side. And I went through a bunch of effort. Unfortunately, I don't have it right here in front of me, but you can, very similar to what I did with the power here, I went through a bunch of effort to find some HDMI cables and things so that I could bring it out of the top there and then go around and put a panel mount jack on here, but this time instead of mounting it this way so that it's actually sticking out, because then it would be sticking out the side, you see, I wanted to mount it on the inside so that the HDMI cable would just go through this hole. So I figured all of this out. I determined where it was going to go, and where I determined to go, the spoiler alert, was right here. So I took this out. I found it actually very difficult to cut through this bamboo, just with the tools that I have. I ended up, sort of drilling and dremeling and things, but I ended up eventually, after a lot of work, making the hole that was going to work, and brought it back in the house and reassembled the box. And at that point I realized that at some point I had flipped this over, and so the hole that was supposed to go up here ended up down here, and the one at the bottom cannot be used because there's stuff behind it, so it's no good, and I ruined this box. Now at that point, a bit of despair, but I went online and I researched where this box comes from, and it is not available in the US. So I had to order it from amazon.co.uk. I bought 2 more of these because this time I know I'm probably going to ruin the next one. And my plan was then to redo the whole thing with what I learned and make it nice and neat, and put the connectors where they're supposed to go, and everything would be great. So I've got 2 of these boxes sitting around waiting for me to do that project. In the meantime, I realized, this being a bamboo box, I mean, it's not a very, one of the reasons it's difficult to cut through here is because the box is already assembled, right? So where do you, if you clamp the bottom of this box to a workbench, you have this whole thing, vibrating. It's not solid, right? Ideally what you'd want to do is have made these holes in here before the box is apparently glued together. So then I thought, well, wait a minute, bamboo is a very common material to work with, so I could just get some bamboo and make my own box, and then I could make the holes in there exactly where I want them. Heck, I have, slightly off camera, right over here, I have a CNC carving machine, so I could make this look really nice. And in fact, in hopefully a month or so, I will have a laser cutter. So my plan now is I've put this on hold, and when I get my laser cutter, I'm going to make a custom box for this, and everything will be wonderful. And all of the connectors will go exactly where they're supposed to go. This box has a dual wall kind of construction. There's the outside part, and then there's the inside part glued in there, which makes sort of a lip. But as I mentioned in the video, this part, there's a metal tab here under this tape, and when you put that on top of the lip, then the front panel doesn't fit properly anymore. So what I did there was I basically chiseled out this section so that that lip is deeper and the board fits inset in there, which then allows the front panel to go on properly. And I think hopefully this time now I will not have to pop this off again for this video. So there's the PiDP-8 replica. It has a special Raspberry Pi distribution that boots up pretty quickly. So if I turn the power on, it only takes a few seconds for the Linux to come up and then start the simulator, and then the lights will start flashing and everything is good to go. There we go. People have put a lot of effort into accuracy here. There's even a thing that simulates the analog light bulbs using the LEDs and a decay algorithm and stuff like that. So overall, it's pretty cool, and essentially just power that up and then I can SSH into it. And as I've put in another video where I demonstrate how you can actually program stuff into it. So overall, this thing is pretty amazing. I'm very happy that I was able to get it, and yeah, and it sits on my shelf and looks cool most of the time, but I'm surprised how much I've actually played around with it. So there it is. That's the story of my instance of this PiDP-8i replica, and now I'm going to put it back on the shelf. Thanks for watching.